Ever pondered over the cosmic mysteries and asked yourself, what if Jupiter, the largest planet in our solar system, became a star? Imagine the bewilderment of gazing at the night sky and spotting not one, but two radiant stars. The second one, not as bright as the sun, yet conspicuously present. That's the spectacle we'd witness if Jupiter, the gas giant that's been our solar system's constant companion, ignited into a star. Jupiter, named after the king of the Roman gods, is no less regal in its own right. It's the largest planet in our solar system, dwarfing Earth by over 1,000 times in volume. It's a gas giant composed primarily of hydrogen and helium, much like our sun. And yet Jupiter is not a star. It sits comfortably in its orbit, the fifth planet from the sun, embodying its planetary status. But the question persists, a question that tickles the imagination and stirs up a sense of wonder. What if Jupiter became a star? This isn't a frivolous question. It's a question that probes the very nature of celestial bodies, a question that demands an understanding of the intricate dance of gravity, mass, and energy. It's a question that opens up a universe of possibilities, both mesmerizing and terrifying. The consequences of such a cosmic event would be far-reaching. It would transform our solar system, our understanding of celestial mechanics, and perhaps even our place in the universe. But before we venture into these speculative territories, it's essential to understand the current reality, the reality of Jupiter as a planet, not a star. Now let's dive into the universe, where we'll explore the consequences of such a cosmic event. We'll journey through the cosmos, from the swirling storms of Jupiter to the fiery heart of a star. We'll navigate the realms of science, speculation, and the sheer beauty of the cosmos. So, buckle up and brace yourselves for a galactic adventure like no other. To understand the scenario first, we need to comprehend the process of a celestial body becoming a star. Indeed, the journey from a simple cloud of dust and gas to a glowing orb of nuclear energy is one that is both fascinating and complex. Stars, like our very own sun, begin their life as a nebula. A nebula is a vast cold cloud of gas and dust in space. Over time, the forces of gravity pull this material together, causing the cloud to collapse under its own weight. This process is slow, taking millions of years, but eventually a dense core forms in the heart of the cloud. This is known as a protostar. Now, for a protostar to evolve into a star, a few key conditions must be met. First, it needs mass. The greater the mass, the greater the gravitational pressure, and this pressure triggers nuclear fusion. This is the process that powers a star, where hydrogen atoms are fused together to create helium, releasing tremendous energy in the process. Second, it requires temperature. For nuclear fusion to occur, the core of the protostar must reach a temperature of millions of degrees. Lastly, the pressure must be high enough to keep the star from collapsing under its own gravity. So, does Jupiter, the largest planet in our solar system, meet these requirements? Well, not really. Jupiter may be massive, but it's nowhere near massive enough. It's only 1,000th the mass of the sun, far short of what's needed to start nuclear fusion. Its core temperature is also much too cool, and the pressure inside Jupiter is not nearly high enough to sustain a star. However, in our hypothetical scenario, let's imagine that Jupiter meets all these conditions. Yes, let's envision a universe where Jupiter has transformed into a star, a second sun in our solar system. What would this mean for us and the rest of the solar system? Well, let's continue this cosmic journey and find out. With Jupiter now a star, our solar system would house two suns. But what does that mean for us? Let's delve into this cosmic conundrum. If Jupiter were to become a star, it would inevitably mean that our solar system would be home to two suns, a binary star system. This isn't as fantastical as it may seem. In fact, binary star systems are quite common in our universe. But what would it mean for our little blue planet? Firstly, let's consider our climate. A second sun would mean a considerable increase in the amount of heat and light reaching the Earth. This could result in drastic changes in our climate patterns, and could potentially make Earth less habitable. We're talking about possible global warming on steroids, which could lead to the melting of polar ice caps at an accelerated rate, and a significant rise in sea levels. Now let's talk about our day-night cycle. With two suns in the sky, we might experience continuous daylight, or at least longer periods of daylight depending on the Earth's position relative to the two suns. This could result in some rather peculiar sleep patterns and could have far-reaching effects on the various ecosystems on Earth. Another key aspect to consider is the gravitational changes. The sudden transformation of Jupiter into a star would significantly alter the gravitational forces within our solar system. This could potentially lead to changes in the orbits of the planets, including Earth's. This might mean that our planet could be pulled out of its life-sustaining Goldilocks zone, either closer to the sun's or further away, both scenarios leading to potentially catastrophic consequences. So, a second sun in our solar system? It's a thrilling thought, a spectacle of cosmic proportions. But with the potential for drastic climate changes, peculiar day-night cycles, and significant gravitational shifts, the reality could be much more daunting. The Earth, as we know it, wouldn't be the same anymore. Jupiter, a proud parent to 79 moons, would undergo drastic changes as a star. But what about its moons? Let's delve into the fate of these celestial bodies. The transformation of Jupiter into a star would indeed have significant implications for its moons. The first thing to consider is the immense increase in gravitational pull that would result from Jupiter's stellar conversion. This could potentially cause the moons to be pulled closer into a tighter orbit, or even be swallowed up by the new star. In contrast, it's also possible that some of Jupiter's moons, particularly the largest ones like Ganymede and Callisto, could withstand this gravitational tug-of-war. They could potentially maintain their orbits, albeit altered, and more elliptical. Now this is where it gets interesting. You see, with Jupiter's new star-like status, the energy output would increase dramatically. This could potentially heat up the moons, possibly even enough to melt their icy surfaces, the result, oceans. Oceans that could potentially harbor life. But it doesn't stop there. The increased gravitational pull and the energy output from Jupiter could cause these moons to take on more planet-like characteristics. Over time, these moons could start to rotate on their own axes, have their own weather systems, and potentially even develop atmospheres. So, you see, amidst the chaos and the drastic changes, there's a glimmer of hope. A possibility that these moons could graduate from their current status and become planets themselves. This would not only redefine our understanding of our solar system, but would also expand our cosmic family. However, it's important to mention that these are hypotheses, possibilities drawn from our current understanding of astrophysics. The universe, as we know it, is full of surprises and tends to defy our expectations. To sum it up, if Jupiter were to become a star, it wouldn't just affect the giant planet itself, but also its 79 moons. This transformation could potentially lead to the birth of new planets within our own solar system. Our solar system's family could potentially expand. With Jupiter as a star, our solar system would be a different spectacle altogether. Imagine, if you will, the vast cosmic arena we call home, now altered in a way we never thought possible. Just as a stone thrown into a pond creates ripples, turning Jupiter into a star would send waves of change throughout our solar system. Firstly, the gravitational balance that keeps our planets in their orbits would be shaken. With Jupiter's new mass and energy, the orbits of the planets could be thrown into disarray. Our familiar neighbors might start to dance in unpredictable ways, their paths shifting and twisting under the sway of this new stellar force. Mars, for example, might find itself pulled closer to the new star, its red deserts bathed in a new fierce light. Or it could be flung outward, sent on a lonely journey into the depths of space. The same could be said for any of our solar system's planets. Then, there's the question of the asteroid belt. This ring of rocky debris, currently held in check by Jupiter's gravity, might be unleashed. Asteroids could be set loose on new paths, becoming potential threats to other planets. The outer planets, too, would feel the effects. The icy worlds of Neptune and Uranus might find their frigid landscapes melting under the heat of a second sun. New oceans could form, transforming these distant planets into water worlds. And what about Earth? Our blue planet, so perfectly situated in the habitable zone, might find itself in a much hotter neighborhood. The delicate balance that allows life to flourish could be upset, with unpredictable consequences for us all. Finally, there's the night sky. With two suns, the concept of night might become a thing of the past. The constellations we've come to know and love might be drowned out by the constant light of a second sun. Our solar system, once familiar, would now be a stranger. As fascinating as this scenario is, how likely is it for Jupiter to actually become a star? Now let's delve into the improbable reality of this hypothetical situation. Jupiter, the largest planet in our solar system, often referred to as a failed star, is in fact far from being capable of starhood. The term failed star might make it seem like Jupiter is just a step away from becoming a star, but that's far from the truth. To transform into a star, a celestial body needs a certain mass to ignite nuclear fusion in its core. This is where hydrogen atoms combine to form helium, releasing enormous energy in the process, which we perceive as light and heat. The Sun, the star at the center of our solar system, has been doing this for about 5 billion years. But Jupiter, despite its immense size, is a lightweight compared to the Sun. It's estimated that Jupiter would need to be about 80 times more massive to spark the nuclear reactions that power stars. To put that into perspective, if we could somehow gather all the other planets in our solar system and add their mass to Jupiter, it would still fall short of star status. Moreover, Jupiter's composition sets it apart from a star. Stars are predominantly composed of hydrogen and helium with traces of heavier elements. Jupiter, on the other hand, has a dense core of rock and metal surrounded by an atmosphere of mostly hydrogen and helium. Its core is not hot or dense enough to trigger nuclear fusion. So as much as we might find the idea of a second sun in our solar system intriguing, the reality is that Jupiter lacks the necessary mass and the right conditions to become a star. This underscores the importance of understanding the reality behind such speculative scenarios. While they might make for exciting conversation and thought experiments, the universe operates according to its own set of rules. While it's fun to imagine, the reality is Jupiter becoming a star is highly unlikely. We've journeyed through a hypothetical universe today, but what did we learn? Our cosmic odyssey took us on a speculative exploration of what might happen if Jupiter, our solar system's largest planet, transformed into a star. We delved into the intricate process of star formation, a cosmic ballet that usually requires an astronomical amount of matter and intense pressure. In this hypothetical scenario, we imagined Jupiter amassing enough material to kickstart nuclear fusion, thereby illuminating our skies with a second sun. We then considered the potential effects of this second sun on our solar system. From extended daylight hours on Earth to the possibility of a warmer Mars, the transformation of Jupiter would undoubtedly usher in a new era of astronomical phenomena. Yet this scenario isn't without its potential dangers. The increased gravitational pull could upset the delicate balance of our solar system, leading to unforeseen consequences. Our journey also took us to Jupiter's moons, these celestial bodies that orbit the gas giant. If Jupiter were to become a star, the fate of these moons would hang in the balance. Some might be engulfed by the newly formed star, while others could find themselves in the Goldilocks zone, potentially becoming habitable. Finally, we contemplated the broader changes in our solar system. With a second sun, the solar system would be redefined. Planetary orbits could shift and new patterns of life might emerge. Yet, while this scenario is fascinating to imagine, it remains firmly in the realm of science fiction. Jupiter simply lacks the mass necessary to initiate the process of becoming a star. However, this hypothetical journey serves a greater purpose. It allows us to appreciate the delicate balance of our universe and the role each celestial body plays in maintaining it. It encourages us to continue exploring, questioning, and wondering about the cosmos. Next time you gaze up at the night sky, remember, the universe is full of endless possibilities just waiting to be explored.